Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. This week on the podcast, we're featuring a series of shows that highlight just a few of the great innovations and innovators at the intersection of three very important and familiar topics: data science, the Python programming language, and open source software. To better understand our listeners' views on the importance of open source and the projects and players in this space, I'm conducting a survey, which I'd be very grateful if you took a moment to complete. To access the survey, visit twimlai.com/Python survey. Please hit pause now and we'll wait for you to get back. That's twimlai.com/Python survey. Before we dive into the show, I'd like to send a huge thanks to our sponsor for this series, IBM. Speaking of open source, IBM has a long history of engaging in and supporting open source projects that are important to enterprise data science. Projects like Hadoop, Spark, Jupyter, and Kubeflow, to name just a few. IBM also hosts the IBM Data Science Community, which is a place for enterprise data scientists looking to learn, share, and engage with their peers and industry-renowned practitioners. There you'll find informative tutorials and case studies, Q&As with leaders in the field, and a lively forum covering a variety of topics of interest to both beginning and experienced data scientists. Check out and join the IBM Data Science community by visiting ibm.com/community/data science. All right, everyone, I am on the line with Rebecca Bilbro. Rebecca is the head of data science at ICX Media and co-creator of YellowBrick. Rebecca, welcome to This Week in Machine Learning and AI.
Thanks for having me, Sam. I'm excited to be here.
I am excited to dive into our conversation as well. This should be an interesting one. YellowBrick is a library focused on visualization, and podcasts are not the best medium for conversations that rely heavily on visualization, but I think we will do okay. Why don't we get started by having you tell us a little bit about your background and how you got involved in data science and what led you to create YellowBrick?
Well, I am a practicing data scientist. I specialize in applied machine learning applications and in natural language processing, usually specifically. Like you said, I currently lead the data science team at a company called ICX Media. So ICX Media is a social video intelligence company here in Washington, D.C., which is where I live. And our focus is on using machine learning and natural language processing and data science to understand what different audiences are currently watching and what they're talking about. And we use that to sort of spot trends and let our clients know how to make more of the kind of stuff that people are going to be excited to watch.
Well, we don't need natural language processing and machine learning to know what people are watching and talking about today.
Well, that's right. So currently there's a lot of dialogue about Endgame and Game of Thrones, but we're not going to talk about it because some people maybe are not up to speed and we don't want any spoilers. But you asked sort of how I got into data science. I always love, I love this part of the podcast. It's so fun to hear kind of how everybody got here. There's a million different stories of how people landed in this field. And so for me, I've always worked in the space between, I would say, like natural languages and formal languages. So as an undergrad, I was a double major. I'm double majored in mathematics and English. And then when I went to graduate school, I decided to study communication and visualization practices in engineering. And so after I finished my PhD, I came to DC, and that was in 2011. And so this was, I joined the federal service as a presidential management fellow. And so this was during the Obama administration. They were putting a lot of kind of focus on, analytics and kind of more data-driven strategies inside the government. And this was just around the time that data science had started really happening. And so my job was basically analyzing like very, very messy data. But I didn't have access to a lot of tools. I mean, I think a lot of public servants can appreciate that, the access to tools is somewhat limited. But in particular, I had a real hard time accessing tools to allow for like wrangling and modeling unstructured data.
Okay.
So I was working with a lot of like logs and reports and manifests and news stories and speeches. And there really just wasn't a lot of tooling out there. And so I taught myself Python and I started building my own tools. And eventually that was my full-time job. And I realized I could kind of take that and make that my full-time job. And I started teaching data science and teaching machine learning because I realized there were a lot of other people who were kind of in the same boat and had a lot of the same kind of needs that I had encountered.
Are you able to isolate what it is that prompted you to take the additional step to start building your own tools? Like I talk to a lot of people on the podcast that learn a programming language because they have some problem. But often, you learn a programming language and the tool set that it offers you, but then building your own tools and then further kind of publishing those and supporting those for others. Like, what is it that even told you that you could do that? Like, what got you down that path?
Oh, that's a great question. So I guess it would be, one answer that I could give is that, I was already in public service, when I getting started doing this. And so I already kind of had this sense that what I was doing was for more than just me, that it was for some greater good. But I think that really the longer that I've been working in open source software and people who are, like you said, kind of building these tools and putting them out there into the world, I would say that open source is a lot less like public service and more like activism. Or maybe for a lot of people, it's more like art, that people are making the change that they want to see in the world. And it's this sort of wild and organic space. And
sounds like podcasting.
It's it's just fun,
Mm-hmm.
It's fun, and once you sort of start doing it, it feels like it feels like the right way to do software.
Mm-hmm. Awesome. So, what is YellowBrick?
Maybe it might help if I sort of give like a little bit of a history of like why we made YellowBrick. So, it really has to do with actually moving to trying to do data science to moving to try to teach data science. And when I started teaching, I realized like how poorly I was able to describe why I was making certain decisions, particularly around the machine learning workflow. And, it's like there's that, Richard Feynman quote, like if you can't explain it to your students or to your kid, you don't really understand it yet. Right. So that was sort of like a moment for me. I realized I was thinking about this. I was talking about this problem a lot with another one of the machine learning faculty that I teach with, who's now my creative partner, Benjamin Bangfort. And essentially what we realized is like what we needed was a way to answer our students' questions the way we would answer them for ourselves. And the way that we were answering them for ourselves was with plots, with plotting routines. And when I say the questions, I mean like the questions the students ask are things like, which features do I need to build this model? Which ones should I remove? How do I know which model to pick? Why is that the right model? Why isn't my model doing a good job at modeling this data? And so that's really why we decided to start working on YellowBrick. And so Ben and I, essentially we started this project sort of in the beginning for our students. But now it's sort of expanded out into being this tool that we see as being useful, not just for students, but for engineers and for professional data scientists who need a way to diagnose and visualize how data is being fit and transformed throughout the entire machine learning process end to end. So it's a pure Python project. It's fully open source. It's licensed under the Apache 2 license. You can find all of the source on GitHub. But yeah, I can say more about it. So it has an object-oriented API. If you are familiar with the Scikit-Learn API, so Scikit-Learn is a very popular Python machine learning library that's open source. So the Scikit-Learn API has this notion of estimators and transformers that can either change data or model data. And so our API sort of wraps that API with common visual diagnostic plotting routines that leverage pure Matplotlib. So that is kind of basically, in a nutshell, what YellowBrick is.
And so you reference that you're using Matplotlib under the covers. What is YellowBrick offering that you can't do with Matplotlib? Is it kind of like pre-configured templates or visualizations? You also mentioned in there diagnostic visualizations as opposed to other types of visualizations. Can you maybe elaborate on all that?
Sure. So to the question about what we offer on top of Matplotlib, it really is about capturing those routines that are kind of become best practices, I think, for people who do machine learning kind of professionally or for their research. So that you like to use residuals plots to diagnose certain kinds of error when you're doing regressions, or that you like to use confusion matrices to know which of your classes you're kind of failing to classify. And so really all YellowBrick does is it sort of says, okay, well, in order to do a residuals plot, you need like these 50 or 60 lines of custom Matplotlib code, or in order to do a confusion matrix, you need these 50 or 60 custom lines of Matplotlib code. And what we do is we wrap those into like an object. And so instead of doing, 50 lines of custom code each time, you just import the object from, you import the class from YellowBrick, and you instantiate an object that executes that work for you inside an object-oriented interface. And so it learns from the data, and then it tells you kind of what it learned using a plot.
Nice. And I would really encourage folks to take a look at the gallery that you've got in the documentation. There are tons of different types of charts and graphs here, everything from feature analysis to regression visualizers, classification visualizers, clustering, model selection, text modeling, decision boundaries, and target visualizers. Are there any particular of these tools that get the most use or are kind of the bread and butter for YellowBrick users?
Oh, that's a fascinating question. Part of me kind of wishes I knew more about how people are using it. One of the ways that we kind of try to keep a beat on this is just by looking at the blog posts that people are publishing. Mm-hmm. What people are using in those posts. It does seem like the regression and classification visualizers are incredibly popular. I think it's because, those are two very common forms of, supervised learning is very common. And so using things like classification heat maps or prediction error plots or residuals plots are very, very popular. We see those a lot in blog posts. There was just a blog post that went out where somebody was using our stochastic neighbor embedding plot, which I really like to use when I'm doing document modeling, right? So when I'm trying to understand a corpus and look at the different kinds of documents in that corpus. And so there seems like people are using kind of the whole gamut. And then the other way that we sort of listen is just by looking in the issues, for feature requests and bug reports to know where people are using different things and how they're using them and what they're encountering as they're trying to use these different kinds of visualizers.
Are there any particular ones? Is there like a kind of lesser known hero among the different plots that you can do that?
I would happy, so I mentioned that I do a lot of NLP at my work, and just kind of in general is sort of, that's my sweet spot in terms of what I like to do. And so, as you might expect, there are, a range of interesting text visualizers that you might be surprised to see, just because they sort of, they happen because Benjamin and I, the other core maintainer, the other co-creator, and I both do a lot of natural language processing. And so we've kind of evolved a lot of these sort of interesting different ways of thinking about text and how, what might help people to model text more easily. And so stochastic neighbor embedding is a common one. So that's, it's like TSNE, TSNE plots. So that's one that we have. We also have ones that people will probably recognize from another library called NLTK. So the Natural Language Toolkit is kind of one of the first really robust Python libraries for doing natural language processing. So we have a visualizer that does like frequency distributions of words or tokens. But we also have a few things that you might not see in other libraries. So we have something called a dispersion plot. And so what a dispersion plot lets you do is see the incidence of a certain word across a corpus, which can be really useful for knowing. It's sort of like a way of doing feature analysis for when your features are words and tokens. Mm-hmm. There's another one called a part of speech tag visualizer. This is one, so I'm sort of selfishly maybe talking about this one because it's one that I worked on recently. But I think a lot about, what kind of document is this? And how can I guess what kind of document this is without having to read every single document in my corpus? And it turns out that one really kind of easy way to guess what kind of document it is to just count the number of certain parts of speech. So like how many adjectives are there? How many nouns are there? How many verbs are there? And so our part of speech tag visualizer is a way that you can like scan over a corpus and look at the proportion of different types of parts of speech. And then you can compare different slices of the corpus or different classes from the corpus and look at how much it varies, right? Because our practices for using certain kinds of words are really, really different when we're talking about blogging and when we're talking about writing news articles, when we're giving speeches. And so you can see really distinct variations in the ratios of different parts of speech.
Can you give some examples of, different ratios and what they signal in terms of the type of document?
Oh, that's a good question. Yeah, I mean, I guess there's that kind of like, when you're writing the news, you're supposed to not use any adjectives. And so that's kind of an easy example, right? So if you're scanning over the text and you do a part of speech tag visualization, let's say, and your proportion of adjectives is extremely low, there's actually a pretty good chance that it's a news article. Whereas, for instance, if you have, a lot of adjectives, you might be looking at something that's more akin to like poetry or music, like a song lyric, because adjectives are a lot more common. So things kind of like that. I don't know if that helps to paint the picture a little bit better.
It does help. I'm not able to easily come up with a lot of different classes that this would easily allow me. It seems like the kind of thing that, and maybe this is like everything else, but you'd have to see a lot of examples to get an intuition for kind of how this might translate to a particular class of documents, and maybe it doesn't generalize all that well.
That's fair. I think, so you did ask,
and that's
about
not a critique. It's very interesting that I'm intrigued that you can learn anything from looking at this consistently. Yeah. And the news example is a great one. I can definitely see that. And I'm just curious about others. It's a very interesting analysis to apply to a corpus.
So here's another example. So I'll sort of think of another example, which is that a lot of times with students, one of the things that they'll try to do is they'll try to do a regression So let's say, they have a bunch of data where each sample is a sample of concrete. And what we're trying to predict is how long the concrete is going to last given, its components, how much of cement is in it, how much ash, how much water, et cetera, is in it. And so let's say they're trying to regress this data. And what they find is that their regression scores are really, really bad. And so one of the strategies that we suggest is why don't you bin the values into categories and then try to do classification. So let's say we'll look at all of the samples that, lasted between 0 and 5 years, all the samples that lasted between 5 and 10. But a lot of times when you sort of manually pick those bins, you end up with really bad class imbalance problems. And class imbalance is the surefire way to end up with terrible classifiers. And so we actually have a visualizer called balance binning.
Okay.
And what it does is it recommends bins when you are kind of trying to turn a regression problem that's not successful into a successful classification problem.
Is the idea that you would use the parts of speech visualizer in conjunction with the binner to allow you to classify documents based on their parts of speech distribution?
Yeah, so I guess for balance binning, I was just thinking about any regression problem that you would want to convert into a classification problem. But I can imagine a case where, let's say we're looking at Yelp reviews, and let's say, we're trying to regress a score, an exact score, for a review is really hard. So trying to predict this is exactly a 4.32 or this is a 2.17 restaurant is really hard. But when you bin things by stars, this is a 1 star, this is a 2 star, this is a 3 star, you can sort of get there a lot faster. So if you don't already have those bins, you could kind of use balance binning to help you decide on the bins. And then you could use something like part of speech tags to see if the parts of speech are a good way to differentiate positive reviews from negative reviews, let's say.
Yeah, I can envision something like fake reviews use more adjectives, for example, than real reviews or something like that.
I think that's a very good hypothesis.
Or more exclamation marks. Is an exclamation mark a part of speech?
Yes. Yeah. So punctuation is included in that.
This was originally built as a teaching tool. Can you maybe talk through some of the ways that you use it or have seen it used in real world? And we've kind of talked through a bunch of those, but I'm wondering if you can walk through in maybe more depth kind of a workflow or use case that you're familiar with.
Sure. So I think that first I would sort of say I think a big part of how I think about the machine learning process is by using this expression, the model selection triple, which comes from a paper by Arun Kumar, which is actually a paper on sort of next generation databases that anticipate machine learning from the start. But he talks about the model selection triple as basically this is what the machine learning workflow sort of boils down to. You do feature analysis, you do algorithm selection, and then you do hyperparameter tuning. And you might have to do a triple, like many triples, to get to the optimal model, but it generally follows that flow. And so what you've got then is a search problem, right? So you're searching, you've got this big grid of all of the possible features, all of the possible algorithms, all of the possible hyperparameters, and you're trying to find the best, place in that search. And so what students generally do is they just Google examples and they kind of copy and paste. But frequently I think people in a production context, right? So if you're in a company, you maybe are just buying machine learning as a service from somebody else, right? So you're paying some company to, like a black box kind of company, you give them your data, they kind of do something magical, and they pass you back a model, and maybe you try to deploy that. But I think that what I am seeing is that people are starting to become dissatisfied with those black box models. They can't tune them. They don't understand them. They don't have a lot of insight into how they work. And there's, ethical concerns with how is this made? How can we answer these questions about how this was made from our users, let's say. And so what I'm seeing is that people are starting to adopt YellowBrick to do steering of the model selection triple and kind of like taking that process back in-house so that they can do it, in-house rather than delegating that or paying for that service from somebody else.
I'm curious, are you seeing folks that are adopting YellowBrick as a path towards more explainable models or understanding the models better? You were just saying that.
Yes. So I think that it is a very powerful tool for model interpretation and explainability. It is not really designed for non-technical, consumption, right? So it's not really designed to kind of produce plots that you could just drop into a business presentation and give to people who aren't already sort of familiar with the process, but they are a very good way to stimulate kind of more directed decision making for your data scientists. So you can, if your data scientists are using YellowBrick to do feature analysis and feature engineering, model selection, and hyperparameter tuning, that they are doing this. It's not a random walk, right? Like they're not just picking things randomly. They're doing a directed, focused search. They're not just using grid search, right? So they're thinking about the choices they're making, and because they're thinking about the choices they're making, and they have these artifacts of those choices, you can then trace back through those choices and say, this is why we ended up with these features, and this is why we ended up with these models. And you can tell that story with these plots that have been generated in the course of modeling. These visual artifacts can be used. They can be used to explain how a model is working to the internal engineering team. And so that level of explainability is oftentimes a blocker to deploying models, right? Because the data scientists know how to make models, but they don't understand maybe very much about software engineering or deployment. And the software engineers understand deployment, but they don't understand kind of, how to, for instance, how to test non-deterministic functions. They don't understand, how to parameterize things so that they will work in a production context. But yeah, you can use YellowBrick for logging, for visual logging. Once you've deployed a model, you can use YellowBrick to generate plots on a regular basis to look for things like model decay. If all of a sudden the classifier starts to perform poorly, that will show up in the plots, and the engineers can know what to look for, and that can be very powerful for explainability and interpretability.
And so is visual logging in this use case where you're tracking model decay, are there specific YellowBrick plots designed for that, or are you just using YellowBrick to display time series data? That's a good question. I don't know of other people who are using this in context other than Benjamin and I both use this in our jobs. And so essentially, what you're just doing is you're outputting, just the way that you would output like an F1 score on a regular basis, let's say, of your classifier. And maybe you compute an F1 score on some regular, routine basis, and you look for a change. Well, instead of outputting just the F1 score, you could output a confusion matrix, or a prediction error plot is another one of our classifier evaluations. You could output a prediction error plot, which would allow you to see not just the F1 score, which gives you the overall, the harmonic mean of precision and recall, but actually be able to see specifically which classes, where the decay is happening. And that is actually really helpful because
It's this, this specific class is where I'm struggling to classify. It's not just kind of overall performance decay. It's decay in a specific way that I can use that information to make decisions about how to fix things.
You mentioned in discussing that the third element of that model selection triple, the hyperparameter tuning, that one of the advantages of using something like, this approach in general really is that you're taking a more principled approach to optimizing your hyperparameters. What are some of the plots that YellowBrick offers that are there specific plots focused on hyperparameter tuning, or is it just, tracking model performance as you're working your way through the hyperparameter space?
We do have a couple that are specifically for hyperparameter tuning. And so one that is very popular is the alpha selection plot. And so, I'm sure you know this, but when you're doing regression, generally the problem is that you need to figure out how to execute enough smoothing so that your model will generalize to unseen data. But there is this sort of question about how much smoothing do I need? And generally the strategy is to grid search that, right? So you say, okay, well, smooth between alpha equals, 0.001 all the way to alpha equals 10. That's a pretty big grid search, especially if you have a lot of data. That grid search could be running for quite a long time. And the worst part is that you don't know maybe if you've even picked the right range. And if you pick the wrong range to look inside, then you never get to the optimal answer. Right. And so one of the things you can do with YellowBrick is use the alpha selection, which allows you to visualize, what the, let's say, regression score is at, some number of cuts of alpha. And what you're hoping to see is some point where your score, goes up, but starts to plateau. And if you don't see that, if you see kind of things hopping around, moving around a lot, or you can sometimes even see if you've picked the wrong range to look inside. Another example that's sort of similar, but outside of regression, is for when you're doing centroidal clustering. So how do you pick the right K when you're doing K-means? Well, you guess. I mean, there are heuristics, let's say, for picking the best K, but generally, I mean, people are mostly just guessing, right? And so in the same way as with the smoothing coefficient, like you don't know how many K to pick, and so you can grid search that. You can pick all of the K from 4 to 400. That is a very long running grid search. And so instead of kind of just trying to throw grid search at it, you can use the elbow plots. So we have silhouette scores and elbow plots, which are two visualizers in YellowBrick that are very useful for centroidal clustering. And what a silhouette plot does is it computes the silhouette score for each of the clusters. So you pick pick K equals 7. Let's say we'll cluster to 7 clusters, and then it will compute for you the silhouette score for each of the clusters, which essentially is just a way of saying like how dense is this cluster and how far away is it from other clusters. And you want them to be as dense and as far away from others as possible. Because that's what centroidal clustering is sort of for, and so you can use that to look for a single K, but because you can use that for a single K, you can actually scale that up so that when you place like a range of K to look in, you can compute the average silhouette score across all of the clusters at each number of clusters. And what you hope to see in your plot is an elbow. So some point where you reach a peak score. And if you get to like a peak score for a certain number of clusters where your average silhouette score for all of the clusters is really high, you've got to the best K. But you might also see something where there's no elbow and it's kind of jumping all around. And usually when I see that, it tells me that centroidal clustering is not the best algorithm. It's not the best model family. And I need to try to pick a different clustering methods, like maybe something that's hierarchical, let's say. So those are two hyperparameter tuning visualizers that I use regularly that I think are very popular.
I'm curious about the community that uses YellowBrick. First of all, how long has YellowBrick been out, and what have you seen over time?
Well, so it's been open source for, I think it's going to be 3 years this month, or maybe next month. So in that time, we have accumulated almost, I think we have 75 contributors now. We have about 2,000 stars on GitHub. And, it looks like we have about 5,000 downloads a month, unique downloads a month via the Python package index, PyPy.
Wow.
So it looks like we have reached a point where it is starting to become, part of just the routine way that people do machine learning diagnostics. It's hard to tell what the breakdown is between, professional data scientists and students. But based on kind of what we're, the feedback that we're getting and kind of what we're seeing, it looks like this is something that is being used across a lot of different communities. And we recently became a NumFocus affiliated project. So I'm not sure if you're familiar with NumFocus. It's, it's a kind of open source umbrella organization that helps promote open source projects, and particularly a lot of the ones that are very popular, like SciPy and Matplotlib and Scikit-Learn. And so we recently became affiliated with NumFocus, which is really nice. It helps us sort of be kind of more hooked into the conversation, and they help us sort of spread the word. We work really hard to reach out to people. We give a lot of talks. We go to PyCon and, PyData events all over the country. Even, we've been to London. We've given talks in Argentina. So we really are doing our best to try to get this out to as broad an audience as we can. Because I think that like the diversity of usage has really made YellowBrick very interesting. So, it's not just things for regression. It's not just things for classification. It's not just things for text, and that's really because we have users who are engaging in this conversation, who are doing all different kinds of things. And it's really made the library much richer over time.
Oh, that's awesome. That's awesome. When was the first feature that, major feature or a different type of graph that went into YellowBrick that you or Benjamin didn't personally build?
Oh, wow. That's such a good question.
Has it been a long time?
It has been a long time. I mentioned the dispersion plots. That was added by one of our contributors, Larry. So Larry Gray is one of our core contributors, and he does a lot of text analysis too. And so he added the dispersion plot. We have a joint plot visualizer, which is for doing pairwise feature analysis, that was added by Prima, who is another one of our contributors. We have a very kind of special approach to doing unit tests. You can kind of imagine that when you're trying to do unit tests for visualizations, it gets a little bit hairy because you have to compare, different plots and see if they're close enough. But one of our core contributors, Nathan, essentially he found kind of a clever way of doing this that we've adopted. That was a really important contribution. We have two other contributors, Kristen and Adam, who have helped a lot with our documentation and getting it basically to a form where, people really enjoy reading the documentation and know where to find things, because things are kind of easily searchable and make sense.
Can you give a quick summary of the approach to unit testing?
Yes. So the trick is that you have to find a way to do visual comparisons. And so what we do is the library, inside the test directory, we have baseline images. And every time we add a new visualizer or change a visualizer, we update those baseline images. And those baseline images tell you, the tests create images, and the baseline images are what we compare them to. And so when the tests run either on your machine or in CI on GitHub, they are building these plots. They're comparing them to the baseline images that are part of the repository, and they're looking at the diffs between the two. So, it's really just like black and white. Like if you actually look at the diffs, it's just black and white, and you're hoping that, you won't see any diff at all. But what actually happens in practice is that different operating systems have slight variations in how they execute fonts or colors, let's say, or, translucency. And so you have to engineer, you have to use like PyTest parameterize or, other tricks with PyTest to say, okay, well, if it's within this range of similarity, we'll call it the same. Close enough.
Okay. Interesting.
So yeah, it's a little bit tricky, but it's a pretty cool trick. Actually, if anybody out there is doing any kind of visual library stuff and having trouble with tests, I would strongly suggest looking at YellowBrick. I don't really think that there's anything else out there like this. So it can be a really good model for people who are having similar kinds of challenges.
Awesome. Is that have you put that visual compare into YellowBrick, or is it a separate thing?
So it's in there in the sense that it's part of our test suite. So like if you go into the test directory, it's all in there. And we have actually a README inside the test directory that even just kind of goes pretty in depth into like what visual comparison means and how it works. So if you're curious about that, you can dig in there. So that is part of the source code.
Well, that's awesome, Rebecca. Thank you so much for taking the time to chat with us about what you are up to and about YellowBrick. Sounds like a really awesome library. Thanks so much.
Thanks. And yeah, everybody keep an eye out. Version 1.0 is going to be coming out probably in the next month. So there's a lot of new stuff coming out with version 1.0. I think people are going to be pretty excited to see it.
Oh, that's a huge milestone. Congratulations.
Thank you very much. We're very excited.
Awesome. Thank you.
All right, everyone, that's our show for today. If you like what you've heard here, please do us a huge favor and tell your friends about the show. And if you haven't already hit that subscribe button yourself, make sure you do so you don't miss any of the great episodes we've got in store for you. As always, thanks so much for listening, and catch you next time.